everyone, welcome back to Call Your Paul. Right, this episode is going to be all about the electrics and how I've ran all the circuits and bits. Right, so one thing you need to bear in mind with this video, being electrics, this is both mine and my dad's profession. We are both electricians. So a couple of things you need to bear in mind. I've not gone over the top, I've put quite a lot of work into this. But bear in mind, I get all materials at trade price, a good discounted trade price, and I'm also not paying for labour. Right, so we'll start off with the most simple bits. Lights at the first as you come in. So I've got 2 feeds here, and then 1, 2, 3, 4, 5, 6, 7, 8 switch wires, all go into different lights. 1 to in here, 1 for the soffit LED lights, 1 for if I put LEDs around here or anything in the patio, 1 for LEDs around the pond on the base, another for LED down lights around the pond, another one for if I build a pergola or anything over the pond, I want to put some lights over the pond in case, and then another switch wire coming down here, so I can put a light on there and a light on there as backdrop lights, or I may need one into the bio chamber. Right, so what I've done, I've taken all my switch wires back to here, so where I'm going to put the consumer unit. I'm going to put all the relays, we're going to put a few smart switches, bits like that in, so you can control by your phone. It'll make it a lot easier and simpler. As you can see, there are a lot of wires. I think in total there's going to be around 26, 27 circuits. So that's quite a lot. Normally you just have a socket and a light. But what I'm doing, as you can see, each individual point has got 1 cable. So they're all going to be on radials. What you can do with consumer units, you have a main switch, you have what's called an RCD, which is a residual current device. It measures the live and then what comes back along the neutral. So if there's an imbalance, if you lose any current to earth, that RCD will shut off at 30 milliamps, which is what you should use a 30 milliamp RCD. There's 2 ways of doing it. You can either get a split load board, what they call it, with a main switch, 2 RCDs, say 1 there, 1 here, and then a row of what they call MCBs either side, which are miniature circuit breakers. The difference, what I'm going to do, is I'm going to use what's called RCBOs. RCBOs are an MCB combined with an RCD. The problem with split load boards is if you have 2 RCDs, and then a row of MCBs, that 1 RCD controls all of the MCBs to the left of it. So if you've got 10 circuits on the 1 RCD, regardless of what fault you have, well, what appliance or circuit goes faulty, that RCD will trip, which means it will take out everything on that RCD, so all of the feeding circuits. So what you can do is you can use RCBOs instead. They are quite a bit more expensive, but it means that only one will trip off. So what I'm going to do, all the air pumps, all the pumps, the UVs, everything is going to be on a separate RCBO. So if I have a problem with one thing, it hopefully, well, it won't trip anything else. So if I'm on a holiday or away for a weekend and I get a problem with, say, with the air pump, at least there'll be 1 or 2 other air pumps still running. It will just be that one what turns off. The same with a pump, I'll still have a pump running. Right, so moving on into the shed, we've got 1 switch wire here, which is also going to go to an outside sensor light just there, and another switch wire here, which is going to go to an RGB floodlight there, and also an RGB floodlight there. You've got to have some colour on the place, you've got to. Right, what we got down here, I've got 4 circuits, they're all labelled up. What I'm going to do, that's just going to be a spare twin socket. Everything else is going to be done on individual single sockets. So that one there is for the UV. So if I run a UV underneath the Backy River, that's for that one. We've also got a socket for anything. I may put a spray bowl or something in the Backy shower eventually, so I've got a spare circuit for that. You've got to put them in whilst you're building the place, otherwise they're not in. The beauty about me putting ducts in the ground, it means that at various points I can pull more cables when I need. Right, so moving around to here, I've got a couple of 20mm flexible conduits coming out. They're going to go up around there into an adaptable box, which will take the drivers and the connections and bits for the LED tape, which is going to run underneath the granite, and also any lights we put at the bottom. Also here I've got a feed for a water softener. Anyone who runs RO or is thinking of running RO, a great way of extending the life of the membranes is to put the water through a softener first. You'll get 2 or 3 times the length of the membranes through a softener, so it works out a fair bit cheaper. Got a feed in here for the air source heat pump. I'll put the isolator on the inside probably, keep it looking nice on the outside. Coming up here in the ducts, I've got a feed for the reverse osmosis unit. Also got a couple of feeds here coming back from the lighting drivers and bits over there going through the ducts. They're wired in 0.75. All the sockets are going to be a 1.5 rubber flex or 2.5 twin and earth. 16 amp radials for all the sockets. There's a couple of rings, one around there, but that's just for extra bits. And these are all 0.75. Moving around, we're going to have 2 air pumps here. So I've got the 2 feeds coming up here, again in 1.5 rubber. Rubber cable, it's proper natural rubber cable this is. HN075 or something like that I believe the code is. Don't quote me on that because I don't know all the codes, but it's quite expensive cable, proper rubber cable is, but it is really good for taking abrasion and all that sort of stuff. If something comes in here, hopefully it won't be able to chew through it and whatever, if you know what I mean. Right, coming up down here, we've also got a feed for the auto top-up. I showed in the last video, this is going to be my auto top-up unit. Got 100 amp main switch in there. The reason I've put a 100 amp main switch in, it's not because I need 100 amp, it's because it's a double pole switch. It means I can easily isolate it there and I don't need to go back to the panel over here to isolate both the live and neutral, as the MCB is only a single pole device. That will sit down there. I've got Cat5 coming up here, so I can have the sensor wires running into a skimmer for the overflow. Well, sorry, the auto top up. Coming round here, I've got twin socket, well, single socket going up there, and also a single socket going round there. Both for security cameras. One's going to be inside the filter house, one's going to be on the pond. Got them all the way around the house, as you can see, cameras everywhere. Coming round here, I've got a feed for an extractor fan. It's always good to keep fresh air flowing in, especially when you're putting your air pumps inside a filter shed. You don't want to be pumping stale air into the pond at all. So you want to be keeping a nice fresh flow through. Moving on from that, I've got feed for the skimmer. Put a single socket up there. I'm also going to put a skimmer feed probably coming up through here because I may put it somewhere around here. Originally the skimmer was going to go here. As you can see, that's why the 2-inch pipe is there. But with building the filter house, I don't think we're going to have enough room. I think it's going to be maybe 10-20mm too short, but we'll see. I may put it there or I may put it there, so I put a feed in there anyway. Coming down here, I've got the O2 for the skimmer and the ozone. Right, when you run ozone through a skimmer, the problem with not running pure oxygen at the same time is the ozone will be, a lot of it will be used up in the air you're supplying to the skimmer. So essentially you'll be getting only a fraction into the skimmer of what you're actually putting out. So what you want to be doing is using a pure oxygen generator or something like an oxygen concentrator before the ozone creator, and then send back to the skimmer, which then gives pure O2 straight into the ozone, straight into the skimmer. Right, coming down over here, I'll put a low level socket in so I can put an oxygen generator down at the bottom here. Put that somewhere around here. As you can see, these are all my ducts coming up. This one here and that one there, they're a little bit more forward because they go out the side and run down the garden. One's going to have pipe in it to run off to the main pond, and one's going to have the armour cables going to the lights outside and also the main feed in. So what I'm going to do for the main feed is, running down from my consumer unit at the moment, I have a 10mm 2-core SWA running all the way down the garden to the cabin. Inside there I've got a consumer unit with a TT earthing system, so I've got an earth rod outside. I'm going to bring a 6mm 2-core from there all the way around the garden up to here on a separate circuit from that pond. So if I get a problem and I need to isolate everything in here, I can turn just this pond off and that pond will still be running. Otherwise, if I take the one cable and loop it between the ponds, to isolate that pond or this pond, I would need to isolate them both. Right, so what I'm going to do, I'm going to bring the SWA up here into the consumer unit. We'll bring 10mm earth down, back out, and we'll put a earth spike down outside, get our earth. And we're following back around here now. So I've got a 2.5 in for a high level socket up here. I need to be able to clean the drain out, bits like that, so I want to be able to easily plug a pressure washer in if needed. I've also got 6mm twin and earth. I'm probably going to change this to a 10mm to be fair, because I'm going to put a little instantaneous water heater up there. Probably put a little sink or something down there, I'm thinking now, a little corner sink unit, because I've got the waste there anyway. And this bottom drain there in the floor I can use for the skimmer and my upflow filters. Coming round at the bottom, going to put another low level socket in down there and one down there. You can't have too many sockets. You're always wanting to plug something in and never being able to find a socket to do it. Right, so I think the last thing for in here, I'm just going to put a couple of lights in. I'm going to centre one in this area and centre one in that area. I'll probably keep it a little bit more this way if possible, because I'm going to have the drum there and the river there and the upflow filters here, so I kind of want it running down the centre. So I'll get two fittings, I'll put them up to the ceiling, see where I need to bring the cables through before we insulate and panel the ceiling out. Right, so I think I've shown you pretty much everything on the first fix of the electrics now, so I'll get a little bit more done. Once I get on to putting the rest of the electrics in, getting it second fix, wiring it all up, I'll do another video on that. But please like the video if you liked it. Please subscribe, check out my other videos, and thank you for watching. See you on the next one. So one last thing about the cladding. You won't be able to tell, but it all went wrong. As always, I tell when it goes wrong, I tell when it goes right. What we did, we were told to use some Osmo oil, it's a different type for the cedar. We bought it, we got it all, but well, oiled it. All of it just went completely white. It stayed white entirely. We left it for a few days for it to dry. It still stayed white. We spent days and days scraping it, rubbing it with white spirit, trying to clean it all off. Managed to get it all off, but it was a lot and a lot of hard work to get it off. So if you do ever use Canadian cedar, don't put anything like that on it.